Warning! The video you're about to watch contains mathematics at the level of differential calculus, also known as Calc 1. All material has an assumed prerequisite of pre-calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. This is another video in the Derivatives of Polynomials and Exponentials series. You should have already watched a video on the theory behind the derivative of polynomials, and also the most recent being computing the derivative of polynomials. So that should be okay. You should now know how to do that. So we're going to focus on a very popular style of question within Calc 1, which is finding the equation of a tangent or a normal line. So let's go ahead and start with the most common of those two questions, which is find the equation of the tangent line to a curve. Notice that in this one it asks find the equations. So this one says it's actually two or more tangent lines. So find the equations of both lines that are tangent to the curve y equals this polynomial, and which are also parallel to the line 3x minus y. This is what I consider to be a very complex problem because, well, it's got a lot of information in it, and it requires a lot of critical thinking to read through it. So if you're like me and you get confused easily, then it might be best to write down explicitly what they're asking for. So I'm going to write down what we need here. We need tangent lines, right? Well, if I write down that, then of course that implies that we'll need slopes and a point, because that's how you get an equation of a line, is to have a slope and a point. All right, great. So far, that's all right. Find both lines that are tangent to the curve and are parallel to this line. Now that last piece, are parallel to the line, means that they give us actually the slopes where we are required to have. So let me go ahead and write that down. These tangents must be parallel to the line 3x minus y is equal to 15. And now I know that that implies we are dealing with the equation 3x minus 15 is equal to a positive y. I just shift things around there. So this will imply the slopes need to be 3. Notice that I haven't done any mathematics yet. I've just clarified the question they are asking me to do. I've written it in a form that's kind of easy for me to understand. So now I know I need a couple lines, and to have lines I need slopes and points, and I need my slopes to be 3 because our lines must be parallel to this other line, 3x minus y is equal to 15. Another confusing piece about this is to note, how are you going to find a point? Well, and also, where does a derivative come into play? Well, the thing here is you have this polynomial that you're handed, and I guess, assuming that this is what they're saying is true, this curve, which is a cubic, it might look something like this. Okay. This curve has tangent lines which will have a slope of 3 only at a couple points. So let's pretend it looks a little bit like this. There's a slope of 3, slope of 3 right there, and maybe a slope of 3 right here. Let's just pretend. So there's 2 points where this curve would have that slope of 3 for its tangent line. And so we're supposed to find what those points are, because remember, we need 2 points and the slope. Right? We already handed the slope, so we need 2 points. Well, let's go ahead and at least start by finding the derivative and setting that equal to our desired slope. You can see this just involves a lot of critical thinking. So y prime is equal to, from our previous video, let's see, we have an x to the third, so we're going to bring down that power and lower the power by 1, minus 3 times x squared, you're going to bring down that power and then lower the power by 1, plus 3x, but the derivative of x itself is 1, so 3 times 1, minus the derivative of a constant is 0. So we have this derivative, and we want its value to be 3. So when is y prime equal to 3 is really what we're asking, because we need the slopes of the tangent lines to be 3 here. So I'll let 3 equal the left-hand side, equals 3x squared minus 6x plus 3. Well, that's not too bad. Now we're back to algebra. I feel like we've gone through the forest of calculus and stepped out into a lovely meadow called algebra. And this will be, let's see, I'm going to actually do some pre-factoring. Since we already know algebra, I do it very quickly. Subtract 3 from both sides and then factor. And so this implies that to get this answer of 3 on the left-hand side, we need x to be either 0 or x to be 2. Well, that's super helpful, because now not only do we know the slope has to be 3, and we found out 2x values, I should say it this way. Now that we know the slope has to be 3, we have found 2x values, 0 and I think it was 2. All we need to do is find their respective y values. Yes, 0 and 2. To find their respective y values, go back to the original polynomial and plug those in. If you plug in 0 for x, you'll get a y value of negative 3. If you plug 2 in for x, you'll get 8 minus 12, which is negative 4, plus 6, which is 2, minus 3, which is negative 1. Double check my mathematics there. 8 minus 4 times 3 is 12, so it's negative 4. 2, yep, negative 1. All right. So we have a slope and 2 points. We're ready for 2 lines. So the equations of the tangent lines, let's make sure that's what they're asking for. Yeah, find the equations of both lines that are tangent to that curve. So the equations of those tangent lines are going to be the following. I'll call it line 1. Well, that's going to be y minus y1 is equal to slope times x minus x1. Clean that up. Doesn't take too long to do that. That's a teeny little bit of arithmetic, really. There we go. So that's our first tangent line. And now we're begging for the second, right? L sub 2. So it's y minus the y value there is equal to 3 times x minus the x value there. Again, clean that up. It's y is equal to 3x minus 6 minus 1 is minus 7. Box that up. I would like to display this just so you can see the actual result here. So let's go ahead and display this in Desmos. So here we have the cubic right there. And I'll go ahead and type in y equals 3x minus 3. And another one, y equals 3x minus 7. Y equals 3x minus 7. And you can see those are 1, 2, well, whenever I move it, it's not going to lock in place. But those are 2 tangent lines to this curve. And they both have a slope of 3 because you could see it from their equations. And so there you go. That answers the original question. Find the 2 equations with slopes equal or parallel to the slope of the line 3x minus y is equal to 15 that are tangent to this curve. Yeah, very beautiful. Now I should say that tangent line questions dominate quite a bit of differential calculus or Calc 1. Every section, likely, you're going to be asked to find the equation of a tangent line. Just always remind yourself, it's just a slope and a point. And the derivative is highly related to slopes of tangent lines. In fact, it is the slope of a tangent line. So that really helps out. Now we're going to go into something that's more along the lines of physics here. A normal line. A normal line is the line perpendicular to the tangent line at a point P. So if I were to draw out, let's just pretend a curve here, and I said, oh, I'm really interested in this point right here. Well, I could find the equation of the tangent line. That would just be find the derivative, so you have a slope, and then make sure you know the name of that point. Now you have the slope and a point, and you have the tangent line. And let me go ahead and just draw that in there. Okay, so that's the tangent line. I'll call it L sub t. Well, by this definition, every single tangent line has a normal line, and a normal line is the line that's perpendicular to that tangent line. So it goes at a 90-degree angle here. That's line sub normal. It goes in both directions, but most of the time we're only concerned with the direction upwards. But anyway, normal line is it's critical in physics because it's related to forces. It's essentially the force that keeps you in your seat when you're on a roller coaster. That's what the normal force is. So in any question that asks you for a tangent line, they could also ask you for a normal line. So in this example, same exact polynomial we faced earlier. This time, they're asking us to find the normal lines to the curve at x equals 0 and x equals 2, which are the 2 points that we had previously. So I guess we're 100% right now. So let's go ahead and compute the normal curves. So here's the deal. Normal lines, which are perpendicular to tangent lines, well, since they're perpendicular, their slopes have to be opposite reciprocals of the tangent lines. Let me write that down. So again, if m is the slope of the tangent line, then -1 over m is the slope of the normal line. And that is from your Algebra 1 course, although it has not been used that much since then, to be very honest with you, because there's no need for it until now. Recall from the tangent line problem that we had first here, we had our slopes of 3 for both of our tangent lines, right? The slopes need to be 3 for the tangent lines for that same curve. So in this case, we need the slopes of the normal line to be a -1 over that 3. And honestly, this is not a calculus problem now. It is just an algebra problem because we have the 2 points. We already pre-computed and knew the 2 points to be 0, -3 and 2, -1. So writing that over on our page here that we're working on, now I just need to find the equations of the lines with slope -1/3 going through 0, -3, and then the second line will go through 2, -1. It's just an algebra problem. There's no calculus here. So just to do this, y minus the y value is equal to the slope times x minus the x value, which will imply y is equal to a -1/3 x. What is it going to be? -3. And the other one, y minus, again, the y value is equal to the slope times x minus the x value. This is not as pretty, but it'll work out. -1/3 x. And what do we have? Positive 2/3, and we're losing 1, so -1/3. Let me just double check that. Positive 2/3. Yep, that's right. And now what we'll do is we'll go ahead and hop over to Desmos and graph these. Here we are. I'm just going to get that more centered for us. And I'll graph in here y equals -1/3 x and then -3. What I'm going to do is use the color green for my normal lines. And let's also do y is equal to -1/3 x and -1/3, -1/3. Okay, and then again, I want that to be green. And then we'll zoom in and take a look at this. So there you go. At this point, which is 0, -3, you see in red the tangent line, and in green the normal line to the curve in black. And at the point right here, which is 2, -1, again, you see the red tangent line and the green normal line. And they do definitely look perpendicular to one another. So there you go. kind of a nice way of doing that problem. And that was it. That was our excursion into tangent and normal lines to polynomials. We will do this quite often for all different kinds of functions, for exponentials, for trigonometric functions, for logarithmic functions. So this topic will not go away. But luckily, it really is just dealing with good old algebra.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.